So hello, and thank you, Jay and Paulo, for your presentations. Ours will feel a bit more like a bit of a classroom, but we'll promise to be quick. And yeah, we got this title, which might be a bit exaggerated, but we needed to publish an article, and this got us a lot of traction. So yeah, and well, the initial, I'm not able to move forward. Okay, I think it's just me there. Okay, yeah, a little bit of an agenda. Yes, who we are, what's the challenge that we're going to talk about, and the novelty that we're proposing, and some validation and areas of applications of the methodology that we're presenting here. Okay, so Abhishek Singh and me, we work as in a digital health department of a pharmaceutical company. Abhi is a machine learning engineer, I'm a data scientist, and here are our contacts. And this image right here on the right, I really like it because I've been working on this area for almost 15 years. And what I was doing 15 years ago was called statistics, and now it's called machine learning. But yeah, it hasn't changed much. But yeah, I always think it's super funny. And yeah. To the topic that we're talking about today, it's about feature importance. So what is feature importance? If you have a model with inputs and outputs, the feature importance is just the score of a specific feature so the importance of a specific feature has on the model. So you necessarily need to have an output to have the importance of this feature. Normally, you can get this importance with the decision trees or random forest or boosting algorithms. And why is this interesting to calculate this feature importance? So we can understand what's the rank of the features in the output model and do what sometimes it's really important to do. It's the feature selection when you have a bunch of columns and you want to understand which ones are the most impactful, so you can remove redundant ones or collinear ones, and to avoid overfitting of the model, and this really speeds up the model and training predictions. Okay, you've learned all of this in school probably, and so I'm talking, but this is really Avi's idea. And when he first came up to me with this idea in November, he was like, okay, I think I created a method that can predict what's the feature importance in unsupervised learning. So I guess most of you know what's unsupervised learning, but unsupervised learning in a very simple way is you have inputs and you don't have an output. And the model will just try to create patterns with the data. So cluster is the most common supervised model. And this has not been really done before to try to create or calculate the feature importance of an unsupervised models. And until now, you could also try to remove some collinear columns when you have these types of models. And if you want to speed up the model, what we normally do in supervised model is we'll try to remove some rows using some type of sampling. But apart from that, yeah, there's really not much that has been done. So the novelty that Abhi will share his approach right now, it has to do with graphs. And this is a novel method which Abhi took advantage of a Google PageRank. And you can know more about going to Abhi's Git and can read our articles towards data science. And yeah, and I will hand over to the man.
Okay, so I think post-COVID, this is the first interaction, right? Okay, so I still as Chris talked about, right? So the problem with unsupervised models are, right, we'll get good homogeneous sets. So I will take it back, right? For example, business comes to us, right, and say, we have this data, now tell me what we can do. And most of the time, when you're in the software engineering or any company, you have a lot of data, but you don't know what I can do, because target is always unavailable, right? You don't know what to predict, because nowadays in modeling people talk about prediction, right? But when you go about unsupervised, there's no prediction. So we are always handicapped. We have to use only clustering, and clustering will give you a good homogeneous set, right? But if you say, okay, what is important out of 100 column? This question is always unanswered, and there is no methods for it, right? So I thought, if I need a directionality, I have to somehow convert this tabular data into direction. Okay. And what we are talking about, we are converting a tabular data in direction using a Google PageRank. Okay, and we'll tell, okay, assume if this is a direction, that is how your rank should be. Okay, and we also prove this concept with the help of dysentery and random forest. We compare with this, those two standard algorithms, and we got good accuracy somehow. Should I print enter or next?
I just pressed
You just got to click
Okay,
down the
click.
way.
Okay.
I think right button also.
Does the right button not work?
It's not working.
No, it
Oh,
does.
it's working. Great.
It's left and right.
Okay, so imagine it's not working. Okay, so I would say, assume this is a raw data where you have just tables, okay, and you have a columns and row, right? Now you will see it looks weird, but that is how I was thinking, or like we were thinking, right? So what I did, I just convert this column and row as a node. So it's like more like column A underscore 1 is one node, column B underscore 2 is another node, and somehow I created a graph. It's a directed graph. It has directionality, and this direction, I assume the way you have created your data frame or the way you are storing a data, that is a direction, at least for the first iteration. Okay, and when we run our next iteration, you will realize we are changing the direction based on the Google PageRank. Okay. Okay. So before we start our ranking, we always have a matrix like number of your rows is number of nodes and the columns is number of attributes available. Okay, for example, if you have a 5 columns, the algorithm runs 5 times, but it will try to compute number of times we have a nodes. Okay. Okay, so let's suppose you run your Google PageRank first time on this given graph and you identify node number C underscore 3 is most important. Okay. What we did, okay, this is the most important node, and but that can be a bias as well. What if you have just 2 label or the 2 category in that particular column? So it doesn't matter, your traffic will always go in these 2 directions, right? So how to remove that bias? Again, I'm going a lot of in theory, but if you don't understand, let me know. Okay, I remove that guy who is most important in the first iteration and see how my graphs looks like. So I'm trying to imbalance my graph and see who is most important really in a given scenario. If I remove the most popular person, okay, and again recompute these guys. Okay, this algorithm go on. Okay, how many times number of columns we have. Okay, and you have all the ranks with you. Okay, this is the first iteration, and then based on we identify the first person in the Google PageRank, he will become the first node for me, because in the graph, you know, whoever is the first, let's say your parent or the root node, and from there traffic go, right? Because of animation. Okay, so if you see, when we start with the default order, this is what your order, column A, B, C, D, but when we compute first time, the order change. Now it's C, B, D, A, and E. Okay, now we redo the same thing again. Okay, and see, okay, who's next? Okay, that is how we are iterating this process. In this case, we are doing 5 times because we have 5 columns. Okay, and every time graphs change. Okay, and in a nutshell, this is how the entire system, like going through the loop. Like this part I already explained in the previous PPT. And once you get your metric, we were doing some calculation, okay, which you can get in my paper, where we will given a detailed walkthrough how the calculation is working. But I understand we are getting a minimum of each iteration. Try to do the aggregation of the attribute level, and then we are sorting them and telling, okay, this is the rank. Okay, this is the like very brief math. Again, I'm sure you will not understand it, but it will give you some information. I'm sure you will see what I'm talking about, but okay. So for us, the major problem was how to prove this approach, because what we were doing in unsupervised model, Nobody can prove, because clustering your, you can say, what they call K-mean clustering, your K-mode clustering, blah, blah, right? Whatever is that, it's proven in the past. And I don't know who did, right? In our case, how to prove those approach, right? So what we did, we taken a 7-8 different type of data sets from the data set which has 5 columns, the sum of data set 35 column, right? And what we did, we iterate over our approach, okay, and we identify our page rank, or like our rank, okay, because this all the data set has a target variable. We run that random forest decision tree, because generally people know this algorithm, okay, and we try to compare how we are close when we don't know the target, okay, and we saw we are almost 80 to 90% close to their page rank. And also there is a scenario, even you run random for a decision tree on the same data set, their ranks are not same, but they have 80% of overlap. We go with the same approach, we'll say, okay, if they are matching 80%, we also go with the same benchmark, okay? And then we see, like we have 8 or 9 different data sets which we have run, you will find on the GitHub as well, okay? And we were 80 to 90% close, okay? And that give us a good confidence this approach is working. And yeah, so if you want to know, okay, where we can use, for example, in my previous companies, okay, don't ask the name of the company, but we use it for knowledge graph. Because if you see nowadays, people are talking about big data, cloud environment, okay. The problem with the cloud environment is you have a lot of softwares, like you name any company like AWS. They say you can host anything, whatever you want. But when system fail, the engineers suffer the most, because they don't know where to fix the problem, because you have a third-party software, you have many more software, right? Where they should go and fix, because n numbers of companies supporting the same, right? For example, they onboard Microsoft product, they onboard AWS, they onboard someone else, right? And they call all software engineers or the support engineers, say, fix the problem. And they say, okay, that's not my problem, okay? So this approach will help you to understand how your systems are interacting with each other, if you somehow know your tabular structure. Same thing, progression of disease if somebody in the pharmaceutical side, because in medical side you will see you have a lot of biomarkers like BP, sugar, right? But you don't know how should I understand whether it will lead to heart attack or something, right? So there's no relation with the biomarker until you really know what you're going to predict. But using this approach, you understand what is the relationship between each and every biomarker. And we also use for simulator purpose, but let's keep it for another day. Assume you have one cloud environment, and this is how systems are interacting with each other. Okay, assume this 56, 7 numbers are how many times you're making a call between the your softwares, right? But let's suppose there is a big event coming up, for example, in AWS, right? What is it? Black Friday, right? Yes, or anything, right? And they want to do the maintenance, but the system is so complex, they don't know what is the most important component in their system. Right? Either they will go with complete restart, and they can't do that, right? So the problem is, for example, if you ask to software engineer, they will say Python because they know the Python, okay? But if you talk to admin guys, they will say HBase, Impala. They will go in the backend side. They will say, okay, no, go ahead and restart these because I have to clean up the memory and all these things. I want system to be fresh, right? So if you use this approach, we know what is the most important, because here I'm not talking about a target. I was talking about how my system are interacting with each other, okay? And there is no relation at the first place, right? So you have to build the relation, and how the relation will be, how they are communicating with each other, okay? And this relation you can derive in n number of ways. You can ask any software engineer, they will tell you, okay? And that way you can say, okay, this is how your systems are interacting. You restart the Spark, not the Python. Then you restart Impala, you restart HBase, okay? And then go to the Python. That is how your restart should go, okay? So those sort of information you will get it from this approach. And let's see, that's the end of the story.